Hey everyone, welcome back. It's Mr. Anderson, and today we're getting together to talk about section 8.2.2 from our CPM Common Core Algebra ebook. And we're going to do this lesson virtually, and the goal today is to talk about some connections between the graph of a function and the equation representation of that function. So we're going to try to do that connection and try to do it reasonably well to give us some visual information from a very abstract non-visual representation. The secondary goal, the other thing that we're going to try to support with some of the learning from that connection, is we're going to talk and introduce the zero product property today, and that in particular is going to enhance our problem solving capabilities. So a very, very important concept in mathematics, and whether you believe me or not, it's probably a concept you're already familiar with, whether you know it or not, right? So here we go. I've got a couple of things put together for us in our notes here, and I kind of took some editing rights out of the book and so on and so forth. So some of these things you'll find in your book, some of them you won't find exactly as I have them, but for the purposes of the e-delivery nature of this video, I had to modify, right? So first question that we're asked is, what do we need to sketch a parabola? And I'll inform you, and this is something I say all the time in class, a sketch doesn't need to be perfect, right? We don't use sketches for exactness. If I was going to make or do a project in class or something like that where I needed precision and accuracy, I would not have a sketch. Okay, I would have a computer-aided graphical design, maybe something like Desmos, but I would not have a sketch. So what do we need to do that? And we've got a couple of leading questions here. The first question is, can you sketch a parabola if you only know what the y-intercept is, right? So we know that a parabola can take on a couple of different shapes. We can have an upward or a downward opening parabola. We can have a very wide opening parabola. We can have a very narrow, skinny parabola, etc., etc. So if I just know that I have a y-intercept, I'm just considering part A here. If I just know I have a y-intercept at 0, -15, here's my x and my y-axis very quickly. Is this enough information at 0, -15 to give me a sketch of a parabola? And the answer is no. No, it's not, right? I don't know if my parabola can open upward or downward. I don't know if it's narrow or skinny. I don't quite have enough information. Well, part B says, what about if I give you the two x-intercepts of the parabola? Can we then sketch it? Well, let's see. Let's say I know the two x-intercepts are -3, 0, sorry, right? The x-intercepts always occur when y is 0. How about that? Well, do you know if it's upward or downward opening? And the answer is no. I don't know enough information to sketch the parabola. And part C then says, well, what if we know the x-intercepts and the y-intercept, right? Certainly 2 points is better than 1. And a logical follow is that 3 points would be better than 2. So if we throw that y-intercept back in there at, right, 0, -15, right? Look at that. Okay, that's better, and now I have some idea of the direction. Now I know that parabola has to do something like that. So is that enough information? It's certainly better, but it's not going to be perfect, right? I still have questions about that vertex. All right, but I do not know exactly what this parabola is going to look like, but it's good enough to be able to sketch it. So for part C, I think once we have those 3 points, the x and the y-intercepts, or the roots and the y-intercept, I think we have enough information, okay? Part D asks me, says, hey, where is the line of symmetry? Remember, from the water balloon problem in the last video, the line of symmetry always occurs halfway in between those two x-intercepts. And if this is -3 and this is 5, right, the halfway point is at x equals 1, okay? And if you're not sure, right, jump in here, make your tick marks, -1, -2, -3, 0, 1, 2, 3, 4, 5, right? That's going to be halfway. I know it doesn't look like halfway with my completely inaccurate sketch, but I think we're doing pretty good, okay? In problem, I'm going to be talking you through 865 here. In problem 864, you learned that if you can find the x-intercepts, then you can sketch the graph without a table. And we did so there. Again, the sketch is not a drawing of perfect, so to speak. What is true about the y value for all x-intercepts? Well, the definition here, folks, is that y must be 0 in order for it to be an x-intercept. Okay? And I kind of hinted at that in the last problem. What is true about the x value for all y-intercepts? And likewise, x has got to be 0. Okay? All right? If x equals 0 at the y-intercept, find the y-intercept of this. And this is actually pretty easy, because if x equals 0, look at this. I can just dump those x terms out. So then what does my y equals have to be? And that is one of the easiest points to find with any parabola. Okay, so that's a really free giveaway if you can remember that, right? Because by the nature of x being 0, the zero products property, we know that those two terms, the squared term and the linear x term, we know that they fall out, right? It is important to watch this sign. Don't forget that the negative does come with the 12, but there we go. Since the x-intercept occurs when y equals 0, the equations, write the equation that you would need to solve to find the x-intercept of this particular graph. Well, if when y equals 0, we know we've got the x-intercepts, because that's the other points we want, I could simply trade out 0 for that y value, and I could rewrite that. Okay, now look at what we've got here. This is a situation we've not quite been in yet. Okay? And part D is going to have us doing something here. It says the roots or zeros of the quadratic expression are the values of x that make the quadratic equal to 0. An x-intercept of the quadratic is called a root. So here we go. Now we're taking this and we're going to do some solving. And ladies and gentlemen, one of the ways that we're going to do some solving is going to require us to recall this skill that we've been building for a couple of video lessons now, all chapter 8. It's going to require us to do some factoring, okay? And I'll talk with you guys about that in just a minute, but before we can factor and solve, we've got to rehearse an idea, and this idea is the zero product property, okay? So the equation we wrote in part C of 865 is called the quadratic equation. I think we're pretty familiar with that now. To solve it, we need to examine what we know about 0, right? And we're going to go through this quickly. There is no doubt in my mind that if I go quickly through this, you may miss something. So do not hesitate to back up and rewatch. Nathan, Sonia, and Gaston are playing a game where Nathan and Sonia each think of a number, then give Gaston a clue about their numbers. Okay? Using a clue, Gaston must tell them everything that he knows about their numbers. Okay, part A. Let's talk about this. Nathan and Sonia's first clue for Gaston is that when you multiply their two numbers together, their result is 0. What conclusion can Gaston make? Well, here's the deal. Nathan's number times Sonia's number equals 0. Okay? Well, what we know mathematically says that the only way we can get 0 as a product is if one of the two factors is 0. So that means Nathan or Sonia's number has to be 0. Or both of them could be 0. All right. Disappointed that Gaston came so close to figuring out their numbers, Nathan and Sonia invite Nadia over to make things harder. Nathan and Sonia and Nadia think of secret numbers. This time Gaston is told that when their three secret numbers are multiplied together, Nathan, Sonia, and Nadia, the answer is still 0. What can Gaston conclude? Well, ladies and gents, one more time, if our product is 0, one of the factors has to be 0, and that's true here as well. So Nathan's number, Sonia's number, or Nadia's number has to be 0, or multiple of them could be 0, right? It's true that 0 times 0 times 0 is 0 as well. Okay, and part C leads us in this little process of induction here. Doesn't matter how many numbers are multiplied. If we have a product of 0, what do you know about one of the numbers? And the answer to that is, if the product is 0, one of the numbers must be 0, and that is called the zero products property. And we use this idea to solve with quadratics. And I'm going to re-examine this equation from part D of 865, and we're going to do some solving, right? Is there a product that equals 0? And the answer is, heck yeah, there is. and we're going to use our generic rectangle to do some factoring, right? Because we have the area up there as a sum, and now we're going to write it as a product. So I've done this with you guys before. Okay? I slap the x squared term in the lower left-hand corner. I slap the constant term in the upper right-hand corner. And now we're going to go ahead and do some factoring. Now, here's the deal, ladies and gents. I'm not going to build this rectangle because some of us are beyond that and ready to move forward. If you need to build the rectangle, though, go ahead, right? We know that the factors of 2x squared are 2x and 1x. Now, the question is, how in the heck can we write those factors of 12 to somehow give us a product of negative 24x squared, right? Because these things need to have the same product. Okay, well, I consider those. I've got like 2 and 6. It doesn't multiply to be negative 24. What else do I got, right? I've got to consider all those options that somehow still add up to 5. And I'm going to encourage you, if you're not ready at this point, to pause the video and go ahead and give it a shot, right? Pause the video if necessary. Go ahead and give it a shot. If you're still watching, I assume you're ready to go. If you haven't paused it, right? Spoiler alert, I'm about to do this one. I'm going to throw a 4 in up here. I'm going to throw a 3 in right here. Okay, now watch what happens. If I multiply the 2x times 4, I definitely get 8x. If I multiply the 1x times 3, I definitely get 3x. Now, I know what you're thinking. You're thinking, Anderson, we need 5x, and 8 and 3 add up to 11, not 5. But remember, my 12 is negative, implying that either the 3 or the 4 needs to be negative. So if the 3 is negative, watch what happens. Okay? Now, 8x times 3x multiplies to be negative 24x squared, and they definitely multiply. I'm sorry, they add to be 5x. Okay? So I'm going to go ahead, and I'm going to rewrite this in factored form. I've got x plus 4, and I've got 2x minus 3, and I'm going to cheat over here a little bit. I'm going to rewrite that equal to 0. And what we're going to go ahead and do here, folks, is we're going to go ahead and we're going to use that zero product property. We're going to treat each one of these things like a number. So I'm going to say either it's the case that x plus 4 equals 0, or it's the case that 2x minus 3 equals 0. Okay, and look at what we've done. We've taken a quadratic and we've written it as a product of linear factors, because each one of these things are solvable. Okay, look at how easy it is to solve this first one. I've got x, and I subtract 4 from each side. I get x equals negative 4. That is a solution. Now, this one's a little tougher. I've got to add 3 to both sides. Right, I'll show the work here, right? And I get 2x equals 3, and then I'm going to go this way. I divide both sides by 2, and I get x equals 3 divided by 2. Now look at this. I've got 2 distinct solutions here. Okay? And this is true for when, I'm going to back up here to the initial onset of the problem, for when y was 0. So what in the heck do these 2 solutions represent? Well, folks, ladies and gentlemen, these solutions, I'm scrolling here, these solutions represent the x values that make my equation true when y is 0. They're my roots. They're my x-intercepts. Okay? That's what we talked about in 8-64. Okay? So we now know the roots and the zeros and or the x-intercepts, and now we can go ahead and make a quick sketch of this parabola. So I'm going to go ahead and do this thing right here. Oops, I got to have the pen. I'm going to go ahead and do this thing right here. I've got an x-intercept here at negative 4. I've got a x-intercept here at 3 over 2. And then, where was my y-intercept? I think that was negative 12, so it's going to be somewhere down here. And I've got it looking something like that. Now, I intentionally went ahead and I tried to make it clear that my vertex was not the y-intercept. Okay? So just be careful on that. That's something that's coming. We don't have the tools for that yet. Ladies and gentlemen, the last thing I'm going to mention is we do have a little review preview. Give these things a shot, and they let us know what kind of questions we have, so don't be afraid to ask them. Thanks for watching. Have a wonderful day.